Hello. So welcome to the first Arduino tutorial. My name is Praveen, and in this series we are going to be talking about Tinkercad. Now, Tinkercad is basically a simulation software for circuits and also Arduino related stuff. Now, if you are hoping to get into Arduino but don't want to purchase hardware or get your hands dirty with it, this is the perfect solution. So let's dive in and see how we can create an account in Tinkercad and then just start using it. So I'm gonna search for Tinkercad on Google. I will try to sign up. Now, if you are a teacher who's trying to teach a class using Tinkercad, the first option for you, the option for you is going to be Educator Start here. And if you're a student who's in a class where your teacher is using Tinkercad to teach your class, you should pick the second one, the green button, Students Join a Class. But if you're like me and just want to try out Tinkercad, create a personal account. And then I will sign in with Google. Select your email address. And voila. So that's it. Now, other than circuits, Tinkercad also offers 3D designing tools. But in this case, we are not interested in that. So I'll go ahead and click on Create and then Circuits. Awesome. That's easy. Now, this is your workspace. Now, let's look at each panel and see what it offers us. Okay, now in your to your right, you'll see the first panel, which is the components panel. Now, as you can see, it hosts a bunch of commonly used components when it comes to creating circuits. So let's pick a resistor, the most simplest one. Now, the moment you click it, your cursor turns into a resistor, and you can see it with the color bands and everything, and place it wherever you want it to by pressing your left mouse button again. Now, the moment you do that, you can see a dialog pops up asking for the name and the resistance. Now, since usually it is common practice to name your resistors as R1, R2, and so on, I'll just use R1 here. And for the resistance, you have to first pick the value, the numerical value, and then the range. So I'm gonna create this to be like a 10K resistor. So 10, and then since it's already kilo ohm, I'll just leave it be. And the moment you do that, you should have seen that the colors change to signify that this is a 10K resistor. Now, if you want to zoom in, you can hit Control on your keyboard and scroll your mouse wheel, and you'll see that the colors signify 10K by saying brown for 1, black for 0, and orange for 3. All right, so I'll zoom out, and then the next thing that we're going to talk about is basically click on the resistor, and then if you want to rotate it, you can go ahead and click this button, which is the rotate button. And if you do that, you'll notice that it incrementally rotates in clockwise direction. Now, you can use a keyboard shortcut for this, which is going to be R key in your keyboard. So that also achieves the same effect. And if you want to delete this component for some reason, you can just go ahead and click on this icon for delete key. Now, if you want to undo maybe you made a mistake, just go ahead and click this button, which is the undo button. And for deletion, you can also use the delete key on your keyboard. Great. Now, let's pick an LED. I call this a red LED. And then instead of the value, you have the color. So you have these colors available. So I'll just pick red. And now, what I want to do here is to basically create a very simple circuit and show you how to connect the components and how to start the simulation. Now, to light up a LED, you need a battery, right? So I'm going to pick this 1.5 volt battery. We'll just start with one. And then we also need a resistor to protect our dear LED from excessive current. As you know, LEDs can only handle around 20 milliamperes of current through them. Otherwise, you'll be effectively reducing their lifespan. So for that reason, we are going to pick this resistor. Now, right now it's a 1K resistor, but I don't care about that. I just want to get the simulation running. Now, if you hover over the leads of the resistor, you'll notice this being labeled as cathode and this as anode. And that is because LED is basically a light emitting diode. So the diode notation applies here. And if you hover above the leads of the battery, it will say negative and positive. So now what I want to do is, first of all, I want to connect my cathode, which is the like a fancy term for negative for an LED, to the negative of the battery. So what I'm going to do is I'm going to click on this lead and out pops a wire. Now this is like moving with your cursor, but what I'm going to do is I'm going to basically click in the middle to create a joint like so. So when you do that, the wire is going to be stationary up to that point, and then I'm going to connect it by making another click on the battery lead. Now once you have a joint like this, you can pull the wire from the joint and just shape it wherever, like however you want it to. So I'm going to like move this LED a little bit to the right, and if you want to like make this perfectly level, you can use the guidelines that will be provided like so. So the moment you bring to a perfect level position, or maybe perfectly perpendicular position, the guidelines appear like so. So not sure why the vertical one is appearing, but basically you can see the horizontal one. And let's connect the resistor this time. I'm gonna like click on the anode, connect it to the terminal 2 of the resistor, and then I'm gonna use another wire to connect the terminal 2 of the resistor to the positive lead. Great. Now let's see. Oh, here. Now here you can see the horizontal guideline as well, and the vertical one. So this means there's a perfect 90-degree angle at this position. Awesome. Okay, now let's tidy our circuits a little bit more, like so. All right, that looks great. Now, as you know, when you organize your circuit, one of the steps that you can take is coloring your wires appropriately. So for an example, when it comes to electronics, we tend to use red wires for positive power, and black wires for connections that are connected to the ground. So in this case, you can also change colors. So what I do is I click on the wire segment and then go to this icon, which is to the wire color. Click on that and you see all these colors that are provided to you. Now since this is my anode, I'm going to pick red, and I'm going to do the same thing to this one, and I'm going to choose black for my ground connection, or else the negative connection. Another handy tool that you can use here is basically the wire type. So click on this wire and then you can pick whether it's a normal wire, hookup wire, or an alligator. So alligators doesn't really make sense, but like you see, like it looks a bit ugly, but Tinkercad basically tries to mimic real world possibilities to the best of its ability. So in this case, you can use crocodile clips, or also hookup wires, which is widely used for prototyping on breadboards. Now that we have our circuit ready, I want to discuss some concepts using this setup. So for an example, first of all, I want to create another circuit of the same configuration. So I want to copy it. So two ways that you can achieve this. First of all, since there's only one circuit of this type, I can just press Ctrl A, which will select the entire circuit, or I can press Shift on my keyboard and then just click and drag to select the area that I want to select. And then Ctrl C, Ctrl V duplicates the entire circuit. And now I have two circuits. Now how do I differentiate between these two? Well, I can add a note. So there's a notes tool here. Click on that, and then you can name your circuit here. So I'm going to call this circuit 1, and this is going to be my control circuit, or else the reference. I'm going to create another note, but this time I'm going to use my keyboard shortcut N. So that creates a note for you. So this is going to be my circuit 2. Great. Now we have labeled our circuits. Now what I want to show you is how the current flow through the LED changes when we increase the resistance of this resistor. Now, how can we measure current? We need to use a multimeter, right? Well, you know what? There's a multimeter in Tinkercad. So since we want to be measuring current, we need to put it in the amperage mode. which converts this multimeter into an ammeter, and I'm going to call it my DMM, which stands for digital multimeter. So just like in other components, if we also have like negative and positive for the multimeter, so what I'm going to do is, since ammeters are supposed to be put in series with the circuit, what I'm going to do is click on this, remove this wire, and select normal. I'm going to connect these like so. I will change the color later on. And let me make this a bit tidier by dragging on these joints. Okay. Alright, so I have perfect 90-degree angles. Now let's color them to be red. Great. Now let's start the simulation and see what's going on here. Click on the start simulation button, and we have 0 amperes. Why do you think that is? Well, it turns out, let's see. The LED is lighting up. You can see a very faint brightness on the device when I stop the simulation versus when I start it. But as you know, LEDs work on 3 volts. So one battery is not good enough. So I'm going to create another battery here. Remove the wire. And to make this entire setup 3 volts, I'm going to put these batteries in series. That means connecting the negative wire of the battery to the positive wire. And then I'm going to hook this up over here like so. So I'll worry about the wiring later and just run the simulation. Awesome. Now you can see a little bit of current, 1.17 milliamperes going through the LED. Now, since we are supposed to be like maintaining the same circuit, I'm going to copy this thing up. I'm going to actually remove the control circuit. But you have to stop the simulation first. Press Shift, Delete. Press Shift, copy, paste. Start simulation. Now you see the brightness is also higher than we had before. Now what I'm going to do is change the resistance and see how it affects. Now changing the resistance you can do while in simulation mode as well. So I think that would be a nice exercise. So I'm going to start the simulation, click on this, and then I'm going to increase the I'm going to decrease the resistance, because like I said, you can actually reach 20 milliamperes. So I'm going to do 500 ohms, and that actually doubles the current going through the LED, but it's still very low. It's like 10 times lower than what we need. So I'm just going to go crazy with this value and make it 5 ohms. Now what's happening? So it's 81.5 milliamperes. That's way too much for the resist LED, and we have a warning. So if you click on the warning, if you hover over the LED, it says current through the LED is 81.5 milliamperes, which is not recommended. Recommended is 20, and the usable lifetime is reducing. So Tinkercad is giving you a warning that you are abusing the LED. So what should we do here? Let's dial down with the resistance. Click here again, and let's put 50 and see what happens. Awesome. That took us almost near 20 milliamperes. Now, no warning, and look at the difference between brightnesses. This is way more brighter than our control circuit, right? So awesome. So that is how you set up a very simple circuit in Tinkercad. And we were able to discuss some concepts like resistance and the brightness, and how to provide the correct values to an LED. Now, the way that we selected our resistance is not ideal. So ideally we should be making a calculation using the Ohm's law and be getting the answer in a more scientific manner. So in the next video, let's discuss about Ohm's law and how we can determine the correct resistance for the circuit. I'll see you in the next lesson. Bye.